Hello, welcome to Chapter 5, Section 6 on graphing inequalities in two variables. Our objective today is I can graph a linear inequality, define its range of solutions, and interpret points as solutions or non-solutions. So, because we're all of a sudden going to do two variables now, we've been doing one variable all chapter, and so we can graph it on a number line, but now that we're going to do two variables, we're going to have to use a coordinate plane. And I want to provide you with some steps here to help you along the way as you start graphing these inequalities. It's going to be kind of different from anything you've done before, but at the same time, we've done most of the hard work already this year. We're just adding kind of one or two more steps. So our step one is to kind of pretend it's something we've already seen, and let's get y alone. Let's get it into slope-intercept form. I'm going to put a note here. We can use our x and y intercepts. We got very good at graphing with those as well, so you can use either of these forms. We like to do it in slope-intercept form, but we can also use our x and y intercepts when appropriate. So we need, then step two is to graph the solution. We're going to make that line, and our line is going to be solid if we have these greater than, less than, or equal to signs, and we're going to use dotted lines if we don't have those equal to, because the line is actually not going to be part of the solution. It's just going to be a boundary for our solutions. I'm going to show you kind of a way, but one way to figure out, we're going to be shading a region, and one way is to test a point, and we almost always just use 0.00 to do that. If it's true, if that's part of the solution set, and I'll show you what this means, we're going to shade that region. Then step three, we're going to test to make sure we've got this right. And step four, we're going to shade the appropriate box. So let's go ahead and grab... So here's some examples of what they mean. Always testing 0.00 using a dotted line, blah, blah, blah. And here's what it looks like. So we've got this equation, y is greater than x minus 2. So I'm going to put a dot here. I'm going to go up 1 over 1, up 1 over 1. And then we're going to test this point 0, 0. So we're going to make y 0, we're going to make x 0. And we're going to find that 0 is greater than negative 2. So we are going to shade this region over here. So these are some examples of ones that have already been done. I want to go ahead and try this with you. So I want you to go ahead and do one or two with me, and once you feel comfortable, go ahead and pause this video and try it on your own. So let's jump into this first one. Well, the first thing that I see that it's already in slope-intercept form. I see my slope, I see my y-intercept. I know that because y is all by itself. I also am noticing before I start graphing that I'm going to graph a solid line, because this line that I'm going to make is going to be part of my solution set, meaning that any point that is on my line is going to be part of the solution along with the shaded region that I'm going to make. So I am going to put a dot at 3, my y-intercept, and I know that I'm going up 3 and over 1. And I can go down 3 and over 1 as well to continue to make this line beautiful. And as you know, we always use a straight edge. I forgot to get mine out of the drawer, but I'm getting it out right now. And here we go. So I'm going to make a solid line. Nice and beautiful. Remember, we want to make these lines beautiful because everywhere on this line is a solution. okay? And if we do not make it really straight, really nice, make sure it's going through points perfectly, then we're not going to be able to see exactly what the solutions are. Now we've got to determine what the shaded region is. And I'm going to tell you that there's kind of two different ways of telling, especially if y is all by itself. The first way, let's write this. Where is the shaded region? I'm going to say one way we can do that is plug in 0, 0, 0.00. It's super easy to plug into equation. That's why we love it. We just plug in the origin and see if it makes a true statement. The other way we can do it is we can say, well, is y greater than or greater than equal to or less than and equal to. If it's greater than, then it's going to be above the line. Y, or the solution to this equation, is going to be above the line. If it is less than, it's going to be below. And I'm going to explain both of those ideas with you right now. So first thing, let's try plugging in 0.00. So I'm going to do that. Plug in 0, 0. And what do I get? I get 0 is less than or equal to 3 times 0 plus 3. Well, 3 times 0 is just 0 plus 3, so I get 0 is less than or equal to 3. So I know that I need to shade the region that has 0.00 in it. 0.00 is on this side of the line, so I am going to be shading this region right here. And I'm saying everything that is to this side is part of our solution set. Now, I also could have said that I see this line and I see that it's a less than statement, so I know that I'm going to be shading below this line. As you can see, even though this is a pretty vertical line, that you can tell that the below region is over here underneath where this line lives, and the above region's over here. It's a less than statement, so it's going to be below. Now, why are we shading a region? That's a big question that I want to answer before we move on. We are shading a region because of this inequality statement. So we've always had an equal sign, and if we have an equal sign, we want to know, if I plug in an x, what exact y do I get? And the answer is always on this line that we make. Well, now what we're saying is, if I plug in an x, what values of y make a true statement if I have a less than value? And so you notice that if I plug in, for instance, 1, well, it's going to equal 6. But to make this a true statement, y not only could be 6, but it could be 5 and 4 and 3 and 2 and 1 and 0 and -1 and -2, on down to negative infinity. Same thing if I plug in maybe x is 0. I get 3, and of course we see that point right here, but I also, if y is 2, it's still a true statement. 1, 0, -1, -2. So we get a huge, what we call half plane of solutions. So we already had infinitely many solutions when we had an equal sign. Now we are increasing the amount of solutions a lot. So we have a lot of solutions. And why do we want to graph this? Because this is really the best way to represent our solutions, so we can see what is possible. And we're going to be doing a lot of things here real quickly to help, to show how it is helpful to be able to graph these things. I've talked enough about that. Let's jump on over here to this other one. Now, I could rewrite this in slope-intercept form. Feel free to do that if you want to. We just subtract 4x from both sides and divide by 2 on both sides. That would be pretty easy to get it into slope-intercept form, but I also want to show you that we can still use our x and y intercepts. If I want to find my x-intercept, well, I'm going to make y equal 0. Right here, y equals 0. And so we get an x-intercept. I'm going to make y 0, and I get 4x is less than 16. I'm going to divide by 4 and divide by 4, and I get that x is less than 4. So this doesn't have an equal sign on it, so I'm going to make this a little small open circle. And then I'm going to do the same thing. If I want to find a y-intercept, I am going to say that x needs to equal 0. If I make x equal 0, I have 2y is less than 16. Y is less than 8 when I divide by 2 on both sides. And so I'm going to have, oh, that's quite the bummer. 1, 2, I'm going to have an open circle up here. So maybe this one is easier if you put it in slope-intercept form, but we're still going to make this work here. Now, you'll notice that I am picking up my pen as I do this. I need to make this a dotted line because we need to be able to see that the solutions on this line are not actually part of the solution set. This is what's called a boundary line. It is kind of containing where my solutions are, but on this line are not part of the solutions because we do not have an equal sign here. Now, I'm going to say if I plug 0 in here, 0 into here, 0 plus 0 is 0. 0 is less than 16. 0 is less than 16. So that all goes to say that 0.00 is part of my solution set, right? So if 0, 0 is part of my solution set, then all of these points over here have to be part of my solution set. And you again see this less than statement. So we're underneath this line, aren't we? So there's 2 ways that we can show what that solution is. Hi, Harriet. Go away. I'm making a video. Okay. So we are on to this statement. Now, what do you want to do? Do you want to find your x and y intercepts? Do you want to solve for y? I definitely want to solve for y. Why don't you try this on your own? Pause the video real quick. See if you can do it. See where your mistakes are. And then you can watch me and fix them along the way. So I'm dividing by 3 on both sides. And I get y is greater than 1/3 x. You see how this is 1x, so you could write it as x over 3, but I love to see my slope there just jumping out at me. So we've got a less than statement, so I know this is going to be a dotted line. We have to say that before we start doing anything else. I've got a y-intercept, I've got a slope. Let's do it. So I'm going to make a circle dot this time to show that that's not part of my solution set, but I'm going to start making my boundary line. And I'm going to go up 1 over 1, 2, 3. And I am going to use my straight edge now. And I have made my boundary line. Now I just need to know what area I need to shade. I see that I've got a greater than statement, which means that it's going to be above the line. The solution needs to be greater than this line that I made. But if you don't believe me, let's check with 0.00. If I plug 0, 0 into here, I get 3 times 0 is less than 3 plus 12. This makes 0 is less than 15. That is not true. Not true. Which means that 0, 0 is not part of my solution set, along with all of the other points I could come up with over here, which means that this shaded region up here is part of your solution set. Now, if you're ever getting these wrong, then you need to start checking a second point. For instance, I could check 0, 5 right here. If I plug 0 and 5 into here, I get 15 is greater than 12, which means this point is part of the solution set, which means this whole thing over here is part of the solution set. This next one should be pretty easy. We're first asking ourselves, are we making a dotted or a solid line? This is obviously a solid line with that equals to statement. So I'm going to make a normal dot here. I'm going up 2 and over 3, up 2 and over 3. I am making a solid line because this is an equal to statement. And it says y is greater than this, so I know it's over here. If I plug in 0.00, I get 0 is greater than or equal to -2. That is definitely part of the solution set, so either method that we have here is going to work for this graph. And that is all. So let me know if you have any questions. I have a couple IXLs that I want you to work on. One quick assignment. And like I said, I'll be around if you need any help with this.